Hello, in this lecture we're going to continue on with the ER model. So today we'll talk about cardinality. I know in the previous lecture the example that we went over had some cardinality information, so we'll go more into that. So this expresses the number of entities to which another entity can be associated with using a relationship. Okay, most useful in describing binary, meaning a relationship is associated with exactly two entity sets. So there are four types: one-to-one, one-to-many, many-to-one, many-to-many. I guess these two are pretty much the same thing, depending on which direction you go to. So here we have entity set called bars and then beers. So bars sells beers and beers is sold by bars, right? So here we are not seeing any arrows, right? So there's not one. This means that this is a many-to-many relationship. So this means that bars sells many beers and then beers are sold by many bars. Okay, so I think the example had Bud as an example. So Bud Light is sold by many bars. Okay, so this is going to be a many-to-many relationship. Okay. So a bar sells many beers and a beer is sold by many bars. Okay, so this is a many-to-many and you will not see any of the arrows here, it'll just be lines. Okay, this is an example many-to-many, so this one goes to two different entity sets, same thing here, and then in both directions it's many-to-many. The next one is called many-to-one. Okay, so each entity from the first set on the left-hand side is connected to at most one on the second side, but an entity from the second set can be connected to 0, 1, or many entities from the first set. Okay, so this is what it looks like. As you can see, from the first set it goes to exactly 1, 1, 1, 1, 1, right? But from here it could go to 2, 1, or none. So this is going to be a many-to-one. I guess if this side and this side were to be flipped, we would just call that a one-to-many. So there's really, I guess, no difference between one-to-many or many-to-one. Okay, so favorite is the relationship here between drinkers and beers. This is going to be a many-to-one. So a drinker has at most one favorite beer, right? They could have a lot of beers that they like, but there's just one favorite, that one favorite beer that you like. So that's the one side of this relationship. But a particular beer, if it's really good, can be a favorite of many different drinkers, right? Including 0. So this is going to be a many-to-one relationship. Okay, next one is one-to-one relationship. Okay, so the relationship called bestseller between the manufacturer and the beers is an example of a one-to-one relationship. Okay, so a beer cannot be made by more than one manufacturer, right? There's exactly one manufacturer that makes a particular beer, right? So that's going to be the one. Okay, and then no manufacturer can have more than one bestseller. Okay, they could have multiple beers that sell well, but the bestseller that sells the most, there's exactly one, assuming there are no ties. Okay, so this is going to be an example of a one-to-one relationship. Okay, so there's exactly 1, 1, and 1. Okay, representing multiplicity. So this shows many-to-one relationship by using an arrow entering the one side. So this could be a little bit confusing if you have a one-to-many relationship or many-to-one. Which side does the arrow go into? So the one that has the one side is where you'll have the actual arrow pointing into it. Okay, and if you have a one-to-one relationship, you're going to be seeing the arrows on both sides of the entity sets. Okay, here is an example. We have two entity sets called drinkers and beers, and there are two relationships. Drinkers likes beers. Drinkers also has a favorite beer, right? So a drinker likes many beers, so there's no arrow going into it, right? Guinness is liked by many different drinkers, so there's no arrow, it's a many. So the likes relationship is going to be a many-to-many between the drinkers and the beers. Now let's take a look at this second relationship called favorite. A drinker has one favorite beer. They could like many different beers, but they only have one single favorite, right? So you have this arrow going into the one side. Drinker has one beers. So notice how the arrow is going into beer side. But a beer can be many different people's favorites, right? So there is no arrow here. This is going to be the many side. Okay, the next one we're going to talk about is total or partial participation. Okay, so we talked about this example before where we have the instructor table and the student. And this instructor is the advisor of a particular student. And I know it's kind of hard to see here, but this is a single line, and here is a double line going into the student. So this means that the participation of student in this advisor relationship is total, meaning every student has to have an association with an instructor, meaning they have to have an advisor. Same cannot be said on this side, right? This is a single line, not a double line, meaning instructor does not have to participate in this advisor relationship, meaning they don't have to advise any student, but student has to have an advisor. Okay, so this is a total participation indicated using a double line. Okay, this is a partial participation, which is in most cases it is partial. It's going to be just a single line, meaning it's optional. Instructor can be advising a student, but they don't have to. Okay. This notation also has to do with the cardinality, but here we are we're specifying the minimum and the maximum value that is allowed. So remember the example for the soccer matches, there were exactly 3 referees, right? So they indicated that using 3.3, right? So the very left number is the minimum and the right number is going to be the maximum number allowed. Okay, so here we have instructor and student, so means instructor can advise 0 or more students. So that was the partial participation where they didn't have to be associated with a student to advise them, right? So that there's that 0 ... So it could be they could be advising 0 student, 1 or many. That's what the asterisk is for. It means there's no limit. A student is associated with exactly 1. So we have 1.1. So they have exactly 1 instructor assigned to them as their advisor. Okay. A student must have exactly 1 advisor. They cannot have multiple advisors. Okay, so that's the notation that we use. Sometimes you will have to use this. A lot of times, one-to-one, many-to-one, many-to-many should suffice. Okay, we also talked about primary keys, right? So these keys provide a way to specify how entities and relations are distinguished. When we are considering these 3 sets, we have the entity sets, relationship sets, and weak entity sets. So individual entities are very distinct, and it's by primary key. Okay, the differences among them must be expressed in terms of a certain attribute. Okay, so sometimes there could be more than 1 primary key in a particular entity set. So the values of the attribute values of an entity must be such that they can uniquely identify the entity. So meaning no 2 rows of data should have the same value for that primary key. Okay, so a key for an entity set is a set of attributes. It could be just 1 attribute, or it could be a set of attributes that suffice to distinguish entities from each other. So a lot of times it's going to be the ID. It could be like a social security number. Okay, you can also distinguish among the various relationships of a relationship set. Okay, so again here you could also have primary key that are associated with relationship types. Okay, there are many-to-many relationships. We talked about this, and one-to-many, many-to-one. I would say these 2 are the same, and there's one-to-one. You could also indicate using the minimum number dot the maximum number allowed. Okay, and then we also talked about weak entity. We have not talked about it. So weak entity set is an entity set where it does not really have a primary key. It has a weak primary key that may not always be unique, meaning more than one row could have the same value. So this weak entity set needs help of another entity attributes. Okay, so someone's name is almost a key for a football player, right? But it is possible that two football players or more have the exact same name, right? So name may not always be unique. So this is not really a good key by itself. It's kind of weak by itself, right? Number in a football jersey number that's not a key because players on two different teams could have the same number, right? And they will. It's very common, right? But the number together with the team name that they're playing at related to the plays on should be unique. So meaning each team, within a team, there's not going to be two different players that have the same number. So here we have players and then team. So players, it has name and number, and we already established the name is not enough to be a key. Number, this is the jersey number, may not be unique because a player from a different team could have the same number as this person or this player. So that's why we have underlined number as to be the primary key, but we also notice that players is in a double rectangle, and this shows that this is a weak entity set. Okay, and then plays on, that's the relationship between player and team has a team name, and it's underlined because that's the key. So player's number along with the team name that they belong to, these together, that is strong enough to be, it's going to be unique, it's strong enough to be a primary key. Okay, so double diamond relationship is linked to a weak entity set. Okay, so if you have a weak entity set, meaning there are no attributes that is strong enough to be a primary key, so we indicate that using a double rectangle. And if a relationship is connected to a weak entity, it also shows double diamond. Okay, so here player's primary key would be the numbers along with the team's name. We sometimes also have redundant attributes. So suppose we have student and department name, okay, and we have a relationship between the two. Student has their ID, name, total number of credits, and then the department name that they belong to. And then the relationship here is student underscore department, and then we have department table or entity set that has department name, building, and budget. Okay, so we model the fact that each student has an associated department. They have a major, right? So we could have a minor, but the department name here I think is the major. Okay, so here we have department name here and here. It's redundant, right? So one of these have to be removed, and which one do you think should be removed? This one or this one? Yeah, this one. So this one, because we have this relationship with the department entity set, we can figure out which department they belong to by using this department relationship. So department name here is not necessary, it's redundant, so we can simply remove it. Okay. So now watch the lecture videos on Canvas. We're still on chapter 6, and then we still have the same exercises for the homework 1. Okay, so we have another exercise here. The Coyote Loan Company wants to design a database to track student loans. Each student attending school is eligible for a loan. A student may have more than one loan. A student may be registered possibly at different times in more than one school, right? Each loan should belong to only one bank. Each bank can approve as many loans as it desires. For each loan, the Coyote Loan Company will track the student's social security number, the name, address, amount of loan, date of loan, the interest rate, which may be different for each loan, and duration of the loan, monthly payment, remaining balance, school ID, school name, address, number of years the student has been in school, bank name, bank branch, and the bank ID. Okay, so I want you to draw an ER diagram using entities, attributes, keys, and mapping constraints, of course, relationships as well. Okay, if you have any assumptions, even this exercise or even homeworks or on the exam, make sure you write these down. So the first thing I look at is when I just read this over and then I kind of try to put a rectangle around the main idea or the key theme, I guess. So those will be your entities sets. So the first thing you should do is figure out which are going to be my entity sets. And once you have those, I would actually work on getting the relationships between those entities. Okay, and once you have those down, I will move on to, okay, what are my attributes for each entities? And then which one of those are keys? And then the very last thing you should do is mapping cardinality. So this would be the one-to-one, one-to-many, or you could specify the minimum dot dot maximum number allowed. Okay, so I will give you guys about 10 minutes. Okay, let's go over it. So here we have 4 entity sets. We have student, loan, school, and bank. Okay, and we have relationship between student and loan. A student borrows a loan, and a bank approves a loan, and student attends school. Okay, so here we have many-to-many. So this is another way of indicating the cardinality. You could have just not done this, but this MN means many-to-many. This means that one-to-many, many-to-one. Okay. So this means that a student can attend many schools, and schools have many students attending it, right? And then we have a one-to-many between student and loan. A student may borrow from more than one loan. Each instance of a loan is regarding a single student. So you cannot have 2 students taking out a loan together, right? So each single loan has to do with a single student. That's why we have one here. If we were not to use this notation, if we were to just use the arrow, this would just be a straight line without the n or the 1, and you would have an arrow going into student. Okay, each loan borrows from one bank only. A bank can approve as many loans as they can. Okay, and we also have total participation here, right? Using a double line. So this means that each instance of a loan must have an associated student that is borrowing, right? So a loan needs a student to participate in this loan, or else that would not be a loan, right? That's why we have a double line here. Same thing here. Each loan needs a bank that they borrow from. So that's why we have a total participation here. Without a bank, there would not be a loan. Okay? And then here we have another one. Each school must have students attending the school, right? If they didn't have any students attending it, there would not be a school. A student may or may not be going to that school. So there is no total participation here. Each loan needs a bank that they borrow from. Okay, so we have underlined all of the primary keys. So a person's social security number is underlined, so that's primary key here. A loan, you can always just make an ID and make that a primary key. So here we have loan ID being the primary key for loan. Okay, we have bank ID being the primary key for bank. Same with the school, we have school ID. Okay, and then we have all these attributes that were all mentioned in this paragraph. Here, interesting, we have 2 attributes that are related to this relationship. Okay, so this start date and end date has to do with this student attending this particular school. So if they go to multiple schools, these values would be different, right? So this student is attending this particular school, and this is the start date and the end date. Okay. And then balance here is a dotted line. So I don't think we have covered this. This just means that this is a derived attribute, meaning it can be calculated using other attributes here from the loan. So using the amount that they borrowed, the payment, the duration of the loan, and the interest rate, we are able to calculate what the balance is, right? So that's why this is a derived attribute, and we indicate that using a dotted line. Okay. So here the assumption was that each loan to a student for a different school is given a unique loan ID. That's why we have an ID here. Okay, so yours may look different than this, but this is just one example of an ER diagram.